F means first, so x times x. What is x times x? X squared. Outer would be x times negative 9. So negative 9x. Inner would be negative 4 times x, which is negative 4x. And then last would be negative 4 times negative 9, which is positive 36. Do we leave it like this?
No.
No. If you can simplify, you should. You only can combine like terms. Like terms will have the same exponent. So x squared is the only squared in this entire problem. So you cannot combine it with anything. So it gets to your final answer. I see we have minus 9x minus 4x. They are like terms, so you're going to add them together, and we get negative 13x. And then 36 you can't add to anything because it's the only number. This is the final answer.
That's it?
That's it. You don't solve for x because do you see an equal sign at all?
No.
So there's nothing to solve for. If it says find the product, you just multiply. We're going to do the left column, so 3, 5, and then the extra problem. You're going to do 2, 4, and 6. I need to sneeze. It left me. Okay, so number 3. Thank you. Number 3, you do first. Y times y will be y squared. Outer would be y times negative 13, so negative 13y. Inner, you get 5 times y, which is positive 5y. And then last, 5 times negative 13 is 50 and 13, so negative 65. If you didn't know that, plug it in your calculator. All right, so I still see y squared is the only squared term. Minus 13y and plus 5y will be negative 8y. And then minus 65. Yes, dear? Not right now. We'll do number 5 first. Number 5 is a little different because it says 4m minus 5 times 2 minus 3m. Just because it looks different doesn't mean that you do anything different. You do the same exact thing. First would be 4m times 2. What is 4m times 2? 8m. So we did first. Outer would be 4m times negative 3m. So negative 12m squared. Remember when you multiply a letter times itself, it's squared? So I did 4m times 3m, or negative 3m. So 4 times negative 3 is negative 12. M times m is m squared. Negative 5 times 2 is negative 10. And then the last term, minus 5 times negative 3m is positive 15m. So this one's just uglier than the rest of them. You need to write it in order. If you notice all the other answers, you descend the exponents. So you start with the highest exponent, which was a 2, and then you went to a 1 exponent, and then no exponent. So here, the highest exponent is 2. So you move that first, minus 12m squared. A lot of times when I'm doing this, I cross them out as I go, so I know I used it already. The next highest exponent would be a 1, but I see I have 8m to the 1 and 15m to the 1. So I can combine those. What is 8m plus 15m?
23m.
Plus 23m. So I got those taken care of. And then is there anything to combine negative 10 with? No, so you just write minus 10. It's a very ugly answer, but it is an answer nonetheless. The last one we're going to do together is this extra one in the center. It's not in your student journal, but it is important. If you're planning on taking the PERT, one of the questions on the PERT practice test looks like this. Because it's commonly gotten wrong. It's not commonly hated. Commonly gotten wrong. It's the same as the rest of these. It's just that students look at this and they just distribute the squared, and that's not what you do. When something is squared, what is happening? It's being multiplied by itself. So this is literally the same thing, yeah, as x minus 3 times x minus 3. So I would rewrite it like this, because this is how you solve it.
Bless you.
Bless you, thank you.
I'm going to move it up here, if y'all don't mind there. All right, so once it's written twice, you do the same exact thing. First would be x squared. Outer would be minus 3x. Inner is minus 3x. And last is positive 9. All right, so are there any terms that we can combine?
Negative 3x's.
Yeah. What is minus 3x minus 3x? Minus 6x. And then plus 9. So this is a very different answer than if you had just said x squared minus 3 squared is 9. This is the correct answer. All right, so we're going to talk about the schedule for the next couple weeks. If you direct your attention to the left side of the classroom, we'll talk about all the fun stuff that I wrote this morning. Starting with the very left of the board, the next test. Your next test is on a Thursday again. It's because we have a bunch of short weeks till the end of the third quarter. We had President's Day, we have facts, and then literally that's the last.
We had facts? Or
we have facts. And then we have one last week.
I was about to say.
You need 4 tests. You've had 2. So your next test is over factoring and solving quadratics using factoring. If you've already done Algebra 2, calm down. All you're going to do is solve by factoring. You're not going to do the quadratic formula, solving by square roots. You're literally just going to factor. Okay? You're going to have a mini quiz on that, meaning like 4 or 5 problems. On 2/27, it's a Tuesday. So it's a Tuesday before the test. Yes, it would be next Tuesday. And then once we do that, we have 1 test and 1 quiz left. The most sacred, not sacred, but I don't know if that's sacrilegious. The most sacred holiday in math is Pi Day. Pi is a number and it's 3.14, so we usually celebrate it on March 14th. We, however, are going to have a test on March 14th. It is, calm down, it is the last Wednesday of the quarter. It's the last opportunity to have a test. I was going to have you do a project, but we're running out of time. We're going to do the project during SAT week when we get back from spring break. So, you have a test that Wednesday, you have a quiz on the 12th, so it's the Monday before. So we're going to celebrate Pi Day on the 15th. It is a Thursday. We are going to all bring in a circular food object. And it is a quiz grade. It is literally the easiest quiz grade of your life. You just, that's fine. So listen. You can bring in cookies. You can bring in a circular thing of brownies. I've seen people bring donuts. That's fine. I've seen people bring a 2-liter because it's technically circular. It's a cylinder. We'll talk more about it when we get closer. You do an activity. I used to do an activity, but y'all.
Stop. That was so disrespectful.
If you guys are in Algebra 2 and Geometry, you would do the activity twice, and there are a lot of you. So we're just going to watch one of my favorite movies, which deals with circles. I will not tell you. It's a real-life movie. It's a good one. Okay?
The Life
You
of
don't
Pi?
need to. This is the first time I've heard someone say that. That literally has nothing to do with a circle. The kid's name is Pi.
Yeah, but he talks about pie throughout it.
I don't care. I've never seen it. So
Oh, it's a good movie. You should
okay.
watch it.
Well, then I will.
Okay.
So that's all. Listen, that's all that we are doing in regards to that. We're going to take prayer requests and then start our new chapter.
Can I finish the rest of
So
those?
chapter 10 is all about the circle. There are 4 sections in it. We're going to learn the first one today, and then we're going to go into factoring tomorrow for a very specific reason. So, we're going to go over the lines and segments that intersect a circle. So, you're going to first draw a circle on your notes. I don't care. Make sure it is somewhat, let's say, like an orange size circle. It does not have to be perfect. You don't have to comment about how weird your circle looks. Nobody is perfect unless you have compass. Okay, so just drawing a circle on your notes.
Oh.
Write it on the paper you have.
Oh, this one?
Yeah. So you're going to learn to identify special segments and lines, draw and identify common tangents, and then use properties of tangents. You're going to learn two theorems. And then other than that. The first thing you need to know about a circle is a set of all points in a plane that are equidistant from a given point called the center of the circle. So a circle is perfect, which is why most of us, unless we have our cup, that's awesome, you can't really draw a perfect circle because it's really difficult to do. You need to have the middle equidistant, so equal in distance to all of the points around the circle. So however far point P is from where my finger is, it has to be the same distance all the way around. Usually you use a compass to draw it. I don't own a compass. Well, I mean I do. I don't own 24 of them for you. Alright, so how you would name this circle, since the center is called P, you would call it circle P. Literally it. You can write it with the word circle P, or it can be written as a circle with a P. That's it. That is how you name a circle. So you have drawn a circle, hopefully you have named that circle, and then we're going to talk about the 5 different types of lines and segments you can have. Alright, so let's talk about these. Lines and segments. So I want you to write on the side the word line.
Can I put it up here?
Yep, that's fine. The only reason I say this is not to insult, but just to be quite frank with you. If you are a boy, a lot of times you do not pay attention to this detail and you get dumb points off for not answering the question correctly. So if you're a boy, hopefully I have your attention at this point. A line has no start and no end. It literally has arrows. Looks like that. You name a line with 2 letters. So I would write that down. So line has arrows. And you would name it with 2 letters. So if you had a line that had AB, sorry, it's super ugly. You would name it with 2 arrows and the letters AB. It doesn't matter what order you name them in. It could be BA, it could be AB. It does not matter. But that is how you name a line. A segment is different. If you had a segment on TV, do segments go on forever and ever and ever?
No, they stop.
They stop, praise the Lord, because nobody wants to hear someone talk that much. Segments, you draw a line above them with 2 letters. So these 2 are often mistaken for each other, and they should not be. So you're going to learn 3 segments, 2 types of lines. So when you go to answer them on a quiz and a test, it won't be the most frustrating thing in the world for me to grade.
That's a segment.
Okay? Yes, that's a segment. So we're going to talk about 3 segments. The first one you should have heard before. So first thing you're going to draw from the center to the edge is the radius. So draw that on your circle. You can color code it if you want to. Does the radius go on and on and on forever and ever?
No.
No, because a radius is a segment whose endpoints are the center and any points on the circle. So the radius could be down here. The radius could be over here. The radius could be over here. A radius starts at the center and goes towards the edge. All right, the next one we talk about is a chord. Just by the picture, does it look like the chord goes on forever and ever?
No.
No, it does not. Okay? A chord is a segment whose endpoints are on the circle. And I want you to ignore the diameter for a second, because I want you to think this with me. A chord is a segment whose endpoints are on a circle. You probably have never heard of this one before, and that's okay. You have heard of a radius, hopefully, and hopefully you've heard of a diameter. A diameter is a chord. What is a chord?
A chord is a segment whose endpoints are on the circle.
A chord is a segment whose endpoints on the circle. So look at this blue diameter. Starts and ends on the circle, but it's not only a chord. What else does it do?
It goes through the center.
It goes through the center. So do you remember how I always give examples like poodles or dogs? but not all dogs are poodles. Okay. A diameter is a chord, but not all chords are diameters. Okay. A diameter is a very specific type of chord because the diameter goes through the center. So the green, that's a chord. The blue, that's the diameter. These three things that you have just written about, they are all segments. So if it asks you to name the radius, you're going to name it with a straight line above it. No arrows, no nothing, straight line, 2 letters. That's how you name a radius, a chord, or a diameter. All right? So you're going to have 3 segments, and you're going to have 2 lines. Any questions about these 3 words? Because the next 2 words you've probably not heard of other than in trigonometry, and they don't mean the same thing. I just scared y'all by saying trigonometry. A secant.
When do you take?
We just took it last chapter. When do you take trigonometry? There's a chapter in geometry, there's a chapter in algebra 2, and then there's a whole class after that.
You don't have to take that class, lady.
Secant is a line. Does it look like it starts and it ends?
Yes.
No.
No, it's got arrows.
It has arrows on the end.
Because a secant is a line that intersects a circle in 2 points. So it has no start, it has no end. It just keeps on going and going and going and going and going and going.
So do we draw this too?
Yes, you draw that too. Because the next word is a tangent. You can see it on the screen. A tangent is a line. It looks like a big deal, but just pause. A tangent is a line in the plane of a circle that intersects a circle at 1 point. Secants intersect at 2. Tangents intersect at 1. And the point where the tangent line intersects is called the point of tangency. All right, so here's how I remember the difference between the two. Secants and tangents, they intersect the circle. They just intersect a different amount of times. If this does not help you, find your own way. But this is really how I remember. Okay, so this is a really elementary way to remember. If this helps you, that's great. If it doesn't, find your own way. So secant starts with an S, am I right?
It does.
It does. It intersects 2 or more times. So the options are intersecting once or twice. S and 2 are both like squiggly numbers and letters, so they go together. Tangent is a straight line letter. 1 is a straight line. I just remember that they look very similar when you write them like this. The other way I remember, you've heard of someone going off on a tangent, right? You start off, oh Lord. You start off at 1 point. You've heard me go off on a tangent. You just didn't know it was a tangent.
I really?
Yeah.
Yes. Having someone say, cheating's all right if you don't get caught. Like that, that's a starting point, and then I just go off on a rant. Okay? So a tangent, you start at 1 point. Point of tangency. All right, so that's how I remember. You can remember any way that you want to, but this is kind of the most I can not dumb it down, but, simplify. Okay, so these 2, tangents and secants, are lines. So whenever you name them, you would name them with a line, or there's one other way. If you only have 1 letter, how do you name a line?
You don't.
You do. If you only have 1 letter. The word line, and then that letter. So those are your 2 options when naming a line. Naming a segment, there's only 1 option. Okay? So we are going to move to the next page in your student journal. Page 282. So it's 2 pages away. Name 2 radii. That looks like such an intense word. It's not.
That's 2 eyes.
It's the plural for radius. The plural for syllabus, you get syllabi at the beginning of a semester. It's not syllabuses. Syllabi. I don't know why we call them buses and not I don't know, that's weird. I don't know. Some words in the English language is weird. So, what I want us to do first, We're going to go through, because this is how passionate I am, we're going to mark which ones are named segments, and then we're going to mark which ones are lines. Okay? That's all we're going to do first. A radius. Is that a segment or a line?
Segment.
A segment. So we're just going to underline it for now. A chord.
A chord is a radius. No, it's a segment. I'm tripping.
It's a segment.
I'm tripping.
It's okay. We're just going to forget. A diameter
Segment.
is a segment. A secant.
Line.
A line. So when we name it, we're going to have arrows. Tangent.
Tangent is a line.
A line as well. Point of tangency.
Neither.
It's neither. It's a point. Okay.
Hey.
So now we're going to go back and actually name them. I did that so that we all are on the same page. This is how you name them correctly. A radius starts at the center and goes towards the edge. The center here is A. Name, well, we can go to the left. AD. Doesn't that go from the center to the edge? Yes, so that is one radius. AD. You could also call it DA. I don't care. Starting, we're going to name all of them, by the way. Starting from center A, we could go toward the right instead. So you have AF.
Yes, Clay.
So listen, whenever you get to your homework, it's going to ask for a certain amount. Since we're doing this together, it does us no harm to name the third one AB. Does that make sense? So when you get to your homework, do the amount it says. But I'm just naming all of them because a lot of the times the student is like, but what about AB? It is a radius. I just didn't have to name all of them. We're just going to name all of them just for that sake. All right, any questions on radius, radii? A chord. A chord starts and ends on the edge of the circle. All right, so I first see
EC.
EC. So it's still a type of segment, so you name it with a little line above it with no arrows. Do you see another?
DF.
DF is also a chord. A lot of people don't see DF because what is DF also?
Diameter.
A diameter. It can be both.
So on the quiz, you would want it for both.
On the quiz, it would ask for like one,
Maybe.
so you could name either of them.
ED.
ED.
ET.
ED does not go through the sentence.
No.
ED is a chord. You're correct.
Yeah.
Look at that. I missed that. ED is a chord. Good job.
How's it a chord?
Because it starts and ends on the center. So you can take a line and cut it. Like you don't have to include the infinity and beyond. This is why labeling it is so important. If you had arrows above it, it would not be a chord. It would be a secant at that point. But since you have this segment, that means that it starts and ends at E and you'd ignore the rest of it. Yes, it is. But you have to name it correctly. When we get to secants, secants cross a circle how many times? 2 times. The only one that does that is ED. But when you name it, since it's a secant, you have to have the arrows above. Because technically it's not correct. So usually there is a mistake on this one because when we get to tangent, we're going to have to do that. But whenever you name it with a line and then one letter, it has to be lowercase. It's a weird geometry rule. But like when we get to tangent, which is what we're on now, the only tangent line is this one, and it only has one letter on it. So we're forced to say line B. Does that make sense? This is just a mistake by the book. It should have 2 letters. So for the sake of naming it, we name it line B. But this one we could have named line ED. And last, point of tangency, meaning the point where the tangent line goes through. Which point is that? Point B. Yes, on the nose. So, okay. Page 281, your student journal. So you have 3 types of scenarios that you're going to have. In a plane, 2 circles can intersect at 2 points, 1 point, or no points. A coplanar circles that intersect at 1 point are called tangent circles. We're actually going to draw a tangent line through circles quite a bit. And then coplanar circles that have a common center are called concentric. What is the root word in concentric?
Concentric.
Center. Meaning they both have the same center. So think of it like a dartboard. So these are your three scenarios. What we're going to do next, you see in the middle there are tangent lines. You're going to be drawing tangent lines through circles. Okay? So that's the part where you just got to get the hang of it, and then it will catch right on. Okay? That's why the bottom, a line or segment that is tangent to two coplanar circles is called a common tangent. So if you look at the red circles, there's a black tangent line, a black tangent line. Those are common to both the circles. There's an internal. Internal means inside, so you can think of this. Internal tangents are going to be between the two circles, and external tangents are going to be outside of two circles. Okay? So there's going to be a pattern between them. These are the three things I wanted you to draw. I apologize. So draw them on your notes. You can draw them in the notes section on 281 at the very bottom of the page.
So we didn't need to draw what we did.
Use blue to indicate common external tangents and red to indicate common internal tangents. So for each of these are the three scenarios you'll have. Circles that don't touch, circles that touch at 1 point, and circles that touch at 2 points. So those are the three options that you have. So let's start with blue indicates external. So we'll start with the external. External. Ooh, that was ugly. Let's try this. External is a line that touches each circle at 1 point. So here and here. So there's one external tangent. Do you think that we could draw another?
Yes.
Yeah, in the bottom. So here's a second external tangent.
Let's do it in the middle.
So, but that's we're talking about external right now. External is on the outside of both of them. Nope, it's not.
No.
That would be between the two of them, which would make it internal. Nope. I'm trying to get to it. So, external, there aren't any others, because if you drew a line over here, is that ever going to touch the second circle?
No.
No. If you drew a line over here, is that ever going to touch the second circle? No. These are the only two external that you're going to have. So write down two external. Now we're going to go to internal tangents. So, is there a way to connect these two circles at 1 point on
Yes.
each of them? There is. You can go one way like this. So there's one internal tangent. Do you think we can draw another?
Yes.
Yeah, the other way. I'm not perfect. This is a little bit inside. So you're going to have two internal tangents. Internal just means between the two circles. External means outside of the two circles.
Ooh. Oh.
So this is the same pattern. If you see any two circles that are not connected, this is going to be the answer. Two external, two internal. Letter B, they intersect at how many points? 1. So can you draw a line through 1 point?
No. Yes.
Yes, you can. That's called a tangent. So we have one internal tangent. I'm telling you, this is the same pattern over and over and over again. So you will catch on to it and be able to see it. Are there any external tangents?
Yes.
How many? 2 of them. There's one on this side, and then there's one on this side. So 2 external. Letter C, they're overlapping each other. Is there a way to draw a line into the circle without intersecting more than once? No, because they already overlap each other, so there is no internal tangent. So no internal tangents, if you want to write that. 0 internal. All right, and then how many external are there? 2 still. 1, 2. So these are your 3 options. When you get to this section in the homework, you can look at these in notes And this is all you're doing. Someone asked me on the homework, do we have to draw the circles? If you don't draw the circles, what are you drawing the lines through? You have to draw the circles whenever you get to this.
Should we put two
Okay?
external?
Yes, I did. Sorry. Thank you.
No problem.
All right, so now we have 2 theorems to learn, and we have finished the whole lesson for today. Okay? You're going to do numbers 7 and 8 on your student journal. It's page 282. So, what I want you to write first is tangent line to a circle theorem. Write this big bold. And I will put it in layman's terms for you. Layman's terms. So be writing this. Layman is like the person that does all the dirty work at job sites. So they're the person that just cleans up after the crew. They're the person that
So basically, the
they're the person that doesn't know anything. So when you say layman's terms, you're bringing them down to
his level.
yeah, simple terms. So tangent line to circle theorem. So you're proving if a line is tangent to a circle. So in order to do that, a tangent line, and so you should be writing this, and a radius have to be perpendicular. Perpendicular. I don't have room, but you guys get the picture. I'll write it on the screen. So in order, it's going to say, is line AB tangent to this circle? In order for it to be tangent, the line in question and the radius have to be perpendicular. What does perpendicular mean?
90
Close. Full sentence. What does it mean?
Two lines that
They
may
intersect.
have to form a 90-degree angle.
So yeah, perfect. So 2 lines that form a 90-degree angle. So the tangent line and the radius line have to form 90 degrees. Okay, so it looks somewhat like this. This red is your radius. This blue is your tangent line. So that was the whole theorem. It sounds really confusing, but it's not. So that's the first theorem. Second theorem is even simpler. Ready? Write down the title, external tangent congruence theorem. So write down the bold, external tangent congruence theorem. So the theorem says if 2 tangents intersect at one point, they're congruent to each other. So it looks something like this. So RS or SR and ST are tangent lines. They both intersect at S. So that means that ST is congruent to SR, meaning if ST is 5.4, what is SR? 5.4, that's all this theorem says. Okay, so if 2 external tangents intersect at one point, those 2 that are formed, the 2 lines, are going to be congruent to each other. These are the 2 theorems that include math. The rest of it include naming lines and chords and whatnot. So we are going to do a couple. You're going to draw this first. Start by drawing a circle. And then point P is your center, so circle. Point P, I'm going to teach you how to draw this. Doesn't matter where on the page, you've got a big white spot up here. Oh, you can pull back, that's fine. So a circle, the center is P. Draw from P to the edge of the circle, that is your radius. After that, draw left. Use your discretion on how to do that. And then connect what's left, and then label everything. So, in order for a line to be tangent, The tangent line and what other line? You just wrote it down. And the radius have to be what? Perpendicular. When they're perpendicular, they intersect and form 90 degrees. So, we have 3 lines here. You need to figure out where the 90 should be. It's saying the radius, which would be PT, and the tangent line. So, tangent line would be ST. That's the one in question. ST. Says in the directions. Would have to form a right angle together. If they form a right angle together, what kind of triangle is this?
Right triangle.
Right triangle. So we need to prove or disprove that this is a right triangle. Is there a certain theorem that helps you prove a triangle is a right triangle?
Pythagorean
The
theorem.
Pythagorean theorem. So you're going to use that here. What is the Pythagorean theorem?
A squared plus B squared equals C.
Perfect. So we're going to use that. We're going to plug everything in. What is the hypotenuse in this picture?
37.
37, because it's directly across from the right angle. So that means 35 squared. You're going to put it on your paper. Do not say the answer out loud. 35 squared plus 12 squared equals 37 squared. So plug it into your own calculator.
Yes.
What does the left side equal?
The left equals 1,369.
What does the right side equal?
1,369.
If they equal each other, is this a right triangle?
Yeah.
Yes, so if this is a right triangle, that means that ST and TP are perpendicular. Which means, yes, ST is tangent to circle P. Okay, so there's this example. I'm going to show you one where it's going to try to trick you, and a lot of you will not pay attention to it.
So these are yes or no questions?
Yes, well, you have to have the work for it.
Yeah.
So remember how this one has this line here? We're going to look at our second example. This is our conclusion. Our second example, do you see that line?
No.
No, there's a very specific reason for that. So draw a circle. So drawing a circle usually requires your pencil in your hand. Michael, Christian, drawing circle. From the center to D is 3. Draw a line straight out, then connect back to C. And make sure you put this 2 in the correct spot, exactly as you see it on the screen. So the way that it's drawn, you're trying to figure out if DE is tangent to circle C. In order for it to be tangent, this line has to be perpendicular to the radius. What line is the radius?
3.
Or what segment? 3, so CD. So there has to be a right angle here. So look at this. This side, and we use the Pythagorean theorem, the side across from the right angle is always the hypotenuse. The way that it looks right now, it looks like CE is 2. That is not the case. Do you see how CE is only written right here? That shows that the right, I'll put in different colors so you can see. That shows that right here is 2. What is the distance from the center to the edge of the circle? The radius. And what's the measure of the radius here? 3. So what is the measure of the entire side? 5. So in a problem like this, if it doesn't have that line that says the whole thing, then you're going to end up using the radius and adding. Okay? Another given is the fact that 2 is not the longest side, and the hypotenuse has to be the longest side. So once you have this, you do the same exact thing. A squared plus B squared equals C squared. What's my A and B? 3 and 4. Good. And then my C is 5, which would be 25 equals 25. So is DE tangent?
Yes.
Yes, it is. If they're congruent, because of that theorem, if RS is 28, that means RT is also 28. Did we solve for X like the directions say 2? No. A lot of people would just circle 28 because they think that's the answer. It's asking for what x is. So you can just solve for x. What would we do first? Subtract 4. So we set them equal. Subtract 4.
6.
24 equals 3x. Divide by 3. And that is all you do on this type of problem.
Is it like this on
That's
homework?
literally it, yes. So the reason, listen, the reason we're going to go into factoring and foiling is because at some point on the homework, there's going to be a squared here. And you would still have to solve the same way. And a lot of you don't remember how to do that, okay? The extra sheet of paper was there so you can write down your homework. So go ahead and write down your homework.
Oh, yeah.